Hello folks, this is the last part of our miscellaneous exercise. It's a part 4 and here we are taking up the last part of the question, 10th question first. Let's see what is the 10th question saying. There is a set A. Let A be the set with elements 1, 2, 3, 4. Set B with elements 1, 5, 9, 11, 15 and 16. And the function f to be defined as 1, 5, 2, 9, 3, 1, 4, 5 and 2, 11. Are the following true? Two subparts are there. First is that f is a relation from A to B, and second subpart f is a function from A to B. Justify your answer in each case. You have to check whether it's a function or whether it's a relation, and if yes, then whatever way you have to tell whether it is correct or not. So suppose say they ask us whether it's a function and whether it's a relation. Let's have it like this. They say that it's given and the reason. Given, so we can have maybe true or false or whatever, and then the reason. Right. So first thing is they ask us whether it's a relation, then they ask us whether it's a function. So let's check. First is f is a relation. That's true. Why not? See, what did we understand about a relation? A relation is a subset of a Cartesian product. So if you have a Cartesian product, then its subset, any subset will be a relation. So this is a subset of a Cartesian product. Now, what is the meaning of Cartesian product? One element from there, one element from here. Any subset is going to be a relation. So it is true, it's a relation. Why? Because f is the subset of the Cartesian product. Subset of the Cartesian product. So it's a relation, that's true. Now, second they are asking if f is a function. That is not true. That's false. Why? So we have to give a counter example. Now what is it? I have told you one pre-image, two images, not allowed. And here we have 2 with the image 9, 2 with the image 11. That is not allowed, and that is the problem why it is not a function. You can say that here we have f of 2 becoming 9, and you also have f of 2 becoming 11. So like it's like, you know, this element 2 from here goes to 9, associates to 9 also, associates to 11 also. That kind of association we don't encourage for a function. It can remain as a relation but cannot become a function. So because we are having 2 images for a single pre-image, that is why this is not a function. So this itself is explanatory. If you want, you can say that there are 2 images for 2 has 2 images, 9, 11, and that is not allowed for a function. So that is why it's not a function. That is our question number 10. Now we can move quickly to the question number 11. Question number 11 says that let f be the subset of z cross z, okay, integers, and f is defined as set of all ordered pairs ab comma a plus b such that a and b, they both are integers. If such a thing happens, is f a function, and justify your answer. Now you have to check whether it's a function. It's new to us. Till now we have only taken one x here and we have taken something here. We have not taken a, b like that, or multiple we have not taken. So in some sense it's slightly new to us, but no problem. We will try to understand it. Luckily it's only integers, so it makes our work easy. Okay, let's understand the function here. F of ab is a plus b. Now as a database I provide you a data that this is not a function. Now because it's not a function, our work is reduced. We only have to find counter examples. Okay, so our work reduces to getting the a's and b's where this thing doesn't happen. Alright, so let's first start with the a. I'll take 2 examples here. In the first case, let me take a as 0 and let me take b as 1, and we'll just observe what happens. If a is 0 and b is 1, let's look at it in respect to this function. What happens? So it's like when we talk about this function, it's f of 0 into 1. That is what is happening here. 0 plus 1, right? Directly put the definition of the function. So when we kind of solve it, it becomes f of 0 equal to 1. This is what we are getting. When we simplify it, we get it as f of 0 equal to 1. Okay, fine. Let's keep it there. And then we'll take one more set of values where we take a as 0, but we switch to b as 2. Okay, again we'll substitute in the function and see what happens. F becomes f of 0 into 2 is 0 plus 2. So when we solve it, it becomes f of 0 equal to 2. Right. So check out for these two values. F of 0 is 1, f of 0 is 2. One pre-image 0 getting two images 1 and 2. Not allowed in a function. Right. So that is why this is not a function. Why? Because no matter, they have not put any restriction on us, they have allowed you to take any values of a and b, but just check if it's a function or not. And when we arbitrarily choose values, we are coming across a pre-image where there are two images, and therefore it is not a function. So we can say that here 0 has two images, 1, 2, therefore f is not a function. Therefore f is not a function. Now it is rude on our part to keep it that way. Let's keep it highlighted so that's very easy to spot, right? So that is about our question number 11. Now we can quickly move to our question number 12, and it's the last question in this miscellaneous exercise, where they give us a set A which elements 9, 10, 11, 12, 13, and they say that f is from a to n natural numbers such that f of n is the highest prime factor of n. Quite strange, we have not seen such a thing. Of course the function is quite familiar, but we are saying it for the first time. F of n is the highest prime factor of that particular n. For such a function, you should find out the range. Okay, let's first say that it is from a to natural numbers, right? So because that f of x as such ready-made, it's not given, let's devise it and let's find out. So to start with, let's first start with the first element, f of 9. By definition, highest prime factor of 9. What all are the factors of 9? 1 is there, 3 is there, 9 is there, and we want highest prime. So that is only 3. So it will be 3. F of 10, highest prime factor of 10. Factors of 10 are 1, 2, 5, 10. And highest prime factor 2 and 5 are prime, out of which the highest is 5. Then 5, f of 11. Oh, 11 is a prime number, great. So directly its highest prime factor is itself. Then f of 12. 12 will have so many factors. It has got 2, 1, 2, 3, then 4 is there, then 6 is there, then 12 itself is there. So out of which the highest prime 3, right? So highest prime is 3. F of 13 is a prime number, so solves all our trouble, and it is only 13. So this, once this is done, range is easy, you know, all the values that comes, that's a range. So these are all our range values, that's it. So therefore they ask us what is the range. So range of f, it will be 3, 5, 11, 3 is repeating, and we have learned set is always well defined where we don't repeat things. So it is 3, 5, 11 and 13. That is the range of a function. So this is how we go about doing the problems in a function. Very, very interesting and very, very important from this year's and next year's point of view. So that is our chapter 1. Chapter 2, we finish the chapter 2 here, and in the next video we start with the chapter 3. Thank you.